Hi, I'm Ravi Mayuram, CTO at Couchbase. We've built a database here, which is, we believe, the next generation modern database, which solves some of the very critical problems that we have had in the relational databases. And we have built this so that it's both available in the cloud and at the edge. And so it's been a journey of a good 9 odd years, and we have had some great customer success, and we are happy to be sort of bringing new products to the market.
So you've been talking about Edge 2.0 lately, and I want to understand what your perspective of the 2.0 is, and how has Edge changed in the last 5 years, for instance, since I had done some work on the State of the Edge report. What have you been seeing? What is Edge 2.0?
I think basically there is a lot more data that is actually sort of moving around in the networks, and you typically find that the edge has always been around in some form or the other. We all have understood it, but we have never sort of taken it to this next logical level of where the true edge is, where so far we have had edge applications where the logic is running on the edge device, but the data is still sitting centrally across multiple hops to the data centers, or sitting in the cloud, in the cloud data centers. From there, the true edge, where it's going to move to, is that both the data and the processing is happening right at the edge, and you can make the decisions at the edge. And this is the fundamental difference in terms of where the edge is going, because there's more compute and more storage capabilities. And the development that we have done in the 1.0 versions were all edge applications where the application logic was sitting on the devices, perhaps, versus the data itself was centrally guarded and sitting in sort of applications and databases, which were multiple hops away and multiple firewalls away. And so whenever we saw the circle of death in our applications, we blamed the network. Half the time it is not the network, it is all the hops that this has to go to fetch the data. So having the data local to where it is being sort of operated on, or where it is being engaged with, is the fundamental shift that we see that is sort of happening. And with more the ubiquity of data, and the sort of where the applications have to scale to sort of planet levels, everything being centralized doesn't work anymore. So you just have to decentralize. So there are two edges happening in one sense. One is the cloud's decentralization to the edge, network edge, if you will. The other is the true sort of human and IoT edge. So these are the sort of the edge. The definition is a little bit fuzzier these days than where it was in the good old days. And this is to explain it in terms that we used to have. We used to have CDN of static content. Now that we are CDNing the data also. So the application is always on and available from wherever you're using, with or without network availability. If network is available, you have a free exchange of data. If the network is not available, still the application is fully functional, which will eventually sort of be consistent with the data that's sitting in the central cloud. Sorry, long answer, but that's how I see the edges evolving. It's not an simple answer.
No, it isn't a simple answer. Other ways to talk about it would be to say that the edge is dependent on what the requirement is. So in the case of what you've been seeing so far, how many hops away would we want to be doing some of the data storage or processing, as opposed to just on the device? 1, 2? How close do you think enterprises are doing this right now? What have you seen so far?
So currently, enterprises, the way they are set it up is that it's multiple hops. From there, now I say that edge is becoming core part of the architecture. That's where the enterprises are moving to, because they're understanding this. But otherwise, typically, what you would see is that the number of hops is one too many. Because there are many instances where the data is sitting centralized in one data center. It's not even geo-distributed. So somebody in Australia has to have multiple hops before the data is actually sitting in a data center in Virginia or something. that we have seen in many customer cases. Or even if they have deployed it in the cloud, it is sitting in some one availability zone in the cloud. From there, the modern databases like what we have built is first is to offer you geo distribution of the data. It's not an easy problem to solve, but you have to solve that so that with a click of a button, you can say this data needs to be geo distributed to 5 data centers. And while you're doing it, don't move all the data, because there are now governance issues and security issues around this. This data cannot go cross this country's border, kind of definitions are there. So honor that and move only the data that requires to be in this new data center where you're sitting. Now, what's the advantage of that? When you do that, then the users, let's say EMEA users, if they're coming operating with your application, they don't have to make the extra hop across the pond to come to the US to fetch the data. So right there, they get the data. So you can see the lag, the performance improvement, usability improvement, and the user interaction improvement is quantifiably measured, and people are seeing this. Now, that's one hop reduction, so to say. You can do further one hop reduction where you can actually, if you have a mobile device or if you're doing something on the true IoT or industrial edge, where actually the sensors and others are actually spewing the data, which is going to a gateway, which is a central, so to say, server, which is running in the industrial premise or even in like cruise lines or airlines, all these places, in planes and trains and ships, where the data is collected, analyzed, and actions taken, and the rest of the data is discarded. Just to give you a very simple example, if you have a sensor which is monitoring lights in a room, most of the time it's going to say the light is on, the light is on, light is on. Only when the light is off, it's information, actually. So that's the only information when the state changes, the only information you need to actually push to a central place. The rest of them you can discard. Currently, with the older architectures, you're pushing all this data to a central cloud, and that's costing you network, storage, memory, all kinds of sort of extra cost. So if you only push that information as opposed to all the data, you get a tremendous advantage, because you're able to, number one, process at the edge and take advantage, and number two, send this data up to the cloud. Now, where you can do further analysis and to say how often should you send out maintenance crews to fix things and stuff like that. That's where we see people taking action all the way from field services to industrial, and in a lot of places you have disconnected use cases all the time. So it's occasionally connectedness is where the architecture is now maturing to, as opposed to fully connected and just disconnected.
So is there a balance between folks wanting to do just sort of that regionalization of data, or the on-premise? You know, how prevalent are each of those types of things, applications?
Yes, I think the application prevalence of sort of moving data to the, so to say, edge or other availability zones and other data centers is way more common than the case of, where I want to completely miniaturize the data and ship only the data is available to you on your device kind of stuff. That is the true sort of mobile or edge computing. Those use cases are also sort of coming up more and more. This is where the industrial versus an IoT sort of scenarios happen. But far more is the use case of, I have a centralized sort of cloud infrastructure. Now not all requests can go to that one central infrastructure. Can I distribute that geo distribution of that data, which is one level of CDNing of the data, if you will. That's one hop of CDN. The second hop of CDN is when you actually bring it down to your device and the IoT edge, if you will. Both are happening. The first one is far more prevalent than the second one.
Well, so a related question then, are edge native applications a thing yet? If they are, how distributed does the database need to be? Is it dozens of locations or hundreds? I guess edge native might also include something about the language that you're programming in, or using Kubernetes or something like that. But I'm also curious about your thoughts about edge native.
Yes, let me just sort of devolve this a little bit. There are two sort of paradigms you have to think about. One is connected application. Other is like disconnected or occasionally connected application. A connected application is how we go to our browsers and start doing something there. That's a connected application. Versus an occasionally connected or disconnected application is like your mobile app, anything that you're looking at over there. So the case of connected application, the problem is one of decentralization, because everything being central causes clogging and slower response times, because just the physical lag of transporting data, there's physics involved. So if you get the data closer and closer to where it is actually being consumed, that is one level of decentralization that's happening. In that case, dozens of databases or tens is good enough instead of one. If you can distribute it globally in a smart way, maybe you can get away with a dozen or 20 in the tens, let's say. Now comes the more interesting scenario, where if you want to extend this application to be available to you, there's always a mobile app. There is also a IoT scenarios, in which case the databases should be in the hundreds and thousands. But they are not all the central database, cloud-oriented database, which has to do, tens of millions in concurrency and hundreds of millions of operations per second kind of stuff. It's not of that volume, but it is still a database which stores data, which allows you to query the data, which allows you to process on the data, equivalent of the functionality, but at a single user level or a small portion of the data, like maybe 1/1000th or 1/10,000th of the data. So you're going to see a armada of databases interacting with each other. And that's how, so to answer your question, at that level, at the edge level, true edge level, you should be seeing thousands of databases or millions of databases, because each device and each IoT gateway will have its own database where you can do. And those databases will interact with each other, where you might choose to centralize some data and keep some data decentralized, and some data you might just keep it at the edge.
And so in that case, how do you, I don't know, maybe it isn't always a problem for each application, but how do you deal with coordinating or synchronizing data across,
yes,
all of those different locations?
Great question. Very good question. This is something that hasn't been solved very well in the database layer in the past, but of course, we have solved it here at Couchbase, where you have a sync capability built into the database. So we think of sort of data to be sort of location agnostic in one sense, as in like either it's sitting in your physical device where you're operating from, or it could be sitting centralized in a cloud. You don't need to know. The sync capability will bring the latest information or the data that you need for your application to work and be always on. And if the network is not available, you will do your work on the data that is, so to say, cached in your database locally, and then it'll sync back with the cloud database whenever the network is available. So yeah, that's the occasional connected paradigm, so to say. Now, 80% of your application you can sort of design this way. There are some areas where you cannot design the application to be fully distributed all the time. For example, if you're making an airline reservation, you cannot do the booking on a disconnected device. You will have to be in a connected situation where you have a full transactional capability and stuff like that. So most of the use cases you can sort of do in an occasionally connected sort of paradigm. Those applications are suited where you can have a database locally. There are some applications which you need to centrally run them. So both paradigms a database needs to solve. So that way the data movement is not a headache anymore. The database layer solves the data movement and data synchronization and data consistency problem. So then you can build your applications on top of it and not worry about this. Whole bunch of backend as a service stuff is taken care of because the data naturally moves between what's in the cloud and what's at the edge.
Well, and I think this ties in a little bit, but I want to find out how. There is a lot of conversation around some different terms: data mesh, data fabric, and now we're starting to see conversation about edge fabric or edge data fabric. Which one of those is the most important to your company, and why? Maybe you can kind of describe what it means to you and how you solve that particular problem.
Yeah, I think most of this sort of the mesh conversation happens at a certain level, simply because you have data that is sitting in operational database analytical database, a search system, a queuing system. Many of these places have the data, but so you need to bring the data together in one place so that you have a central way of getting access to all this data from the application. And so that mesh, which is going to the connective tissue or the glue that you need, we have had this in the past also. The data fabric is a very old conversation that has been around for a while. And of course, the edge, sort of, how do you say, is the same paradigm. It's about distributing the data. And so do you need a edge fabric or edge mesh versus a central mesh? That's both are required, and both have a purpose to solve based on your deployment architecture. At the end of the day, it comes to your application deployment architecture, where you could have a mesh topology or a tree topology or a network topology, however you want to deploy your application. This data fabric has to sort of connect those the various sources of your data. From our own perspective at Couchbase, we have taken the sort of approach that the modern database has to solve more than what traditional systems solve. If you see what had happened in the history is that relational systems came and became popular, then came search systems, then analytical systems, then caching systems, and all these systems came. Whenever you put each of these systems, they solved one problem really well. But what they demanded was that you take the data and cast them in a different manner so that each of these applications can work. So you normally have, your data would originate in an operational database, and you'll move it to a search system, you'll move it to a caching system, you'll move it to an analytics system. So you're copying the data multiple times. And so that each of these applications, the way this was rationalized is that we are now moving the data to applications. What needs to happen is that the application logic comes to data. So moving data to logic versus logic to data is the paradigm shift that we need to actually achieve. At a certain level, that's what we have done at Couchbase, where you can write the data once into the database, and then you can have a key value. You can have a full query, a relational sort of query on the same data. You can do information retrieval or search on the same data. And finally, you can sort of do analysis, which is ad hoc querying on the same data, all in one platform, one system, without you having to move the data. So this is one way of sort of consolidating and bringing more different types of logic to that data, versus moving the logic to moving the data to from system to system to system. So this sort of reduces your sort of sprawl of data and reduces the surface area of threat, and sort of simplifies administration, maintenance, and accelerates development. So that's one way of solving this problem, and that's what we have sort of done here. So mesh is an integral part of all this conversation, and people are looking for simplified solutions as opposed to, otherwise you're adding one more, infrastructure,
another layer of fabric on top of everything.
Correct. And it just makes it worse, because it's now you have made it an n-squared problem, even more sort of exponentially more difficult than before. So this is one way of offering a solution which is at least simplifies the landscape for people.
Well, one of the challenges that I think Couchbase has talked about as well on earnings calls, but other people experience this as well, is now that we've explained what an edge application is, there are different people to sell it to. Maybe you can explain the difference in approach to edge applications that app developers and enterprise architects have, and what that sales process looks like, what their difference in perspective is.
At a certain level, the sales process per se is not so different from the selling motion perspective, but you are absolutely right in that the category of, or the classification of developers that you're sort of actually addressing when you're talking about edge and mobile is a very different persona from, let's say, a classic enterprise sort of a connected application kind of stuff. So in terms of our segmentation, understanding, and sort of approaching this, we approach the mobile developer for their class of concerns, which is different from a connected enterprise application, which is all about performance and scale and concurrency and those sort of issues. That's where the highlight of that is. Versus in the mobile case, it's about the simplicity of you being able to write a disconnected application, and then all the synchronization of data and connecting it to the backend sort of application, because it's not always just single point of connectivity. You're talking to multiple things in the back, and so it's to explain to mobile developers sort of how quickly they can stand up a edge application and how quickly it can connect to the backends and how the data transfer can happen. So in that lies the clarification, the simplification, and the tooling. Their tool chains are different from the enterprise to the mobile developer. So it's about us communicating how simply they can basically start with their Android or embedded application and how quickly they can stand up an application from that standpoint. Very different from talking to a JavaScript, Node.js, Java application developer who is developing a connected app. So in that, there is a difference. But from a business standpoint, many enterprises have taken the approach of saying that we want to modernize our field services application, or we are introducing smart metering, or my oil rig. We need to enable something in the rig which is different from what my connected onshore stack is. So it's a business decision in terms of where they want to take their next initiative and so from that perspective, we don't see that the selling motion is different from enabling the developer to go develop these kinds of applications. So that's the distinction I just generally want to draw here.
Excellent. Good. Well, Ravi, thank you very much for joining us today and talking about Edge 1.0, 2.0, and beyond. I appreciate it very much.